The compound that can't act as both oxidizing as well as reducing agent is, and the list of compounds provided for us are, and the given list of compounds are H3PO4, that is phosphoric acid, HNO2, that is nitrous acid, H2SO3, sulfurous acid, followed by hydrogen peroxide, that is H2O2. If I write the structures, if I write the oxidation numbers, if I write the possible other nearby oxidation numbers where there is a chance of oxidation as well as there is a chance of reduction, then we will know whether the given compounds in them, out of the given compounds, which of them is having a chance to act as both oxidizing as well as reducing, and which of them is not having ability to behave as both oxidizing as well as reducing agents. Before going in details, let us have a look over the complete structure as well as oxidation number of the optional compounds. For thorough understanding, the structures of H3PO4 and other compounds are, this is H3PO4, H3PO4 known as phosphoric acid, and this one is HNO2 known as nitrous acid. This is nitrous acid having one lone pair over here. Whereas sulfurous acid, if I write the structure of sulfurous acid, this is sulfurous acid. Whereas hydrogen peroxide, this is hydrogen peroxide. These are the structures of the compounds. If I write the oxidation number with the second method, if I calculate, suppose if I want to calculate phosphorus followed by hydrogen always maintains +1, whereas such of hydrogens by number 3, oxygen always maintains -2 regularly, so therefore that is -2. As being it is a compound, the total sum will becomes equal to 0. So therefore phosphorus -5 is equal to 0, hence that implies phosphorus is equal to +5 is the oxidation number. Similarly, in case of nitrous acid, that is nitrogen plus 1 minus 4 will becomes equal to 0. Nitrogen -3 is equal to 0, hence the oxidation number of nitrogen becomes +3. If I go for sulfurous acid, H2SO3, whereas sulfur plus 2 hydrogens +2 as well as 3 oxygens, -6 is equal to 0. Sulfur -4 is equal to 0, hence sulfur shows +4 is the oxidation state. Sulfur shows +4 is the oxidation state. In case of 2 oxygens followed by here 2 hydrogens, +2 should becomes equal to 0. 2 oxygen should becomes equal to -2. For each oxygen, oxidation number is found to be -1. If we regularly observe after this formula, if I keep only the oxidation numbers there, now it appears as phosphorus with +5, nitrogen with +3, sulfur with +4 and oxygen with -1. Whereas nitrogen, if you look at, nitrogen can increase its oxidation number to some other possibility, that is +5, decrease its oxidation number to any of the minus value like -3, -5, 0, like these chances are there. If I go for the sulfur, sulfur can enhance its oxidation number, as being its group number is 4, it can change to +6, and lower oxidation numbers like 0 it can shows sometimes, +2 it can shows -2, it can shows -4, it can shows some other oxidation numbers like this. Whereas oxygen, it can decrease to -2, it can increase to 0 also. So therefore these 3 compounds in which nitrous acid, nitrogen, sulfurous acid, sulfur, and the hydrogen peroxide, oxygen, is having chance to increase as well as decrease. But if I go for phosphorus here it is showing +5, there is a chance of decrement, it can shows +3, it can shows 0, but there is no chance. +5 is the highest, hence it doesn't undergoes any kind of oxidation, hence it is not acting as reducing agent. Whereas remaining compounds act as both oxidizing as well as reducing agents, but this compound is acting as only one variety. It is acting as, it undergoes reduction, hence it is acting as oxidizing agent, it can't act as reducing agent.